Some of you didn't. Hopefully you guys got at least to the part of the notes where there was a diagram of the star, right? I want to talk about that, and I want to talk about Newton's canon. So Newton's canon is really just an analogy. Newton wanted to explain how the planets or the moon's orbit, how they get into this cyclical movement where they're always going in the same orbit. How does that happen? So he used the canon as an example. I'm going to have you guys flip your lids because some of you are distracted, and let's talk about what this means. Let me put this down. So first of all, we have rocky bodies out in space. Rock, doesn't matter, doesn't have to be a circle. And they are moving in space. Nothing in space is standing perfectly still. Okay, everything is moving in space. Even our sun is moving. We orbit the sun, but even our sun is in motion. What causes these bodies and the celestial bodies to move? Brennan?
Other objects.
Sorry?
Other objects.
Explain what you mean by other objects.
Like other planets that are pulling on it with gravity.
Oh, so the gravity causes things to move. Okay. So that the black hole keeps it together, but something was pushing it away. Starts with we learned about it on our notes. You had to read an article on page 37, Nikolai. Oh, inertia is part of the story, but that's not the word I'm looking for right now. Brennan?
Normal force.
No, normal force is what we stand on, okay? So think about the article you guys read on page 37. Starts with the letter N, nebular. Right, so there is a nebular explosion. The pen is drying out. There is a nebular explosion. Right, and it explodes. It's like a dying star, it explodes. And that explosion, girls at the back, if you could look this way, the explosion sends all of the debris. Maybe it's rocks, maybe it's gases, maybe it's dust, but it sends everything in an outward direction. Outward in every direction, right? Not just in one direction, but in every direction from the explosion. So let's say that this rocky body is being projected. So this is an applied force. The explosion is an applied force, right? And it's sending it in a direction. Okay, it's sending it in a direction. But as it gets close enough to let me move this a little bit more this direction. As it gets closer to another body, there's a second kind of force. Javen, what's the second force that's going to work? We have applied force from the explosion. The second force is what? No normal force, not here. Nikolai, what do you think? Gravity, yes. So the gravity, so right there in the center of this star or a sun, okay, the center of the star starts to pull this in, and it no longer can keep a straight line, and it starts to pull it in. Now, somebody said inertia. I can't remember who said inertia. Okay, but what is inertia? It's Newton's first law. Nikolai, can you tell us what inertia is? Okay, so it's any object in motion wants to stay in motion, right? Wants to stay in motion. Did you say straight line? In a straight line, there's one more thing. There's actually two more things that we have to write. So an object in motion wants to stay in motion in a straight line. Anybody else remember this part? No. How long ago did we learn this? You guys are forgetting. Nikolai? I can't hear you. Oh, that's the third thing I'm looking for.
More mass, more mass.
Yes. I'm looking for speed. So an object in motion wants to stay in motion in a straight line with the same speed. The speed doesn't change. The speed stays the same. Straight line, same speed, unless it's acted on by an unbalanced force. Right? Okay. So here we have, because of the applied force from the explosion, we have an object in motion moving at the same speed in a straight line until it's acted on by gravity, right? So now it's no longer going in a straight line, is it? Because there's an unbalanced force, the gravity is pulling on it. So now we've got this sun pulling this into its orbit. Why doesn't this planet, and maybe some of them actually do, but why does this not go straight to the sun? Why doesn't the sun or the star just suck it right in? What do you think, Joy? Why do you think we don't get sucked into the sun? Why are we staying in a nice circle? Say again? Why? Why doesn't it just get sucked in? Why is there an orbit?
Because the sun's moving so fast sideways that it's missing the ground. It's missing its course of hitting the sun.
Say that again about the speed.
It's going fast enough.
What's going fast enough?
The Earth.
Okay, the Earth or this rock is going. So we have enough speed so that we balance it all out. This pen is not writing. Okay, so we balance it all out. So we balance the forces. Okay, if the gravity is so big, it might be too big and we'll suck it right in. But if we can get to a point where they're balanced, there's enough applied force and an even amount of gravity, it's going to just start going in an orbit. So we've got this balance of gravity and a balance of applied force that keeps it in its gravitational field. Okay? Does that help explain the notes the way I was? I just wanted to go over it again, make the connection between Newton's canon and how things stay in orbit. Okay? All right. So I've got a worksheet